My name is Stephan and I'm from SURAGUS. We produce carbon fiber testing equipment, and I want today give you a short introduction into this new technology using eddy currents. So what are we talking about today? First I give you a company introduction, then I talk about the technology, the use cases and the market, and the products. Okay, SURAGUS comes from surface Argus. Argus is a guy from the Greek mythology, seeing everything, so this is why we named our company SURAGUS, because we can see very well into the material. We have our production and R&D department in Dresden. Where is it? You don't see it there. Okay, this is between Berlin and Prague. We're constantly, right now, 25 engineers, and we are constantly growing. We were founded in 2010, so we try to grow with 5 engineers per year. Okay, our eddy systems are introduced actually everywhere in the world, and we work also with local partners in the world. You see here that we work with partners in China, Singapore, and Turkey as well. Our technology is eddy current-based testing, and I will explain that in the next slide. And we test mainly carbon fiber materials, but also we have another company branch checking thin films. Okay, how does eddy current works? So what we do is we take a coil and inject an alternating current, which then creates an electromagnetic field. And if this electromagnetic field hits a conductive material, this is very important that it has to be conductive, as carbon fiber is conductive, it will create eddy currents within that material. And these eddy currents will create a countermagnetic field, and we can measure that. And this will then picked up by our receiver. To make it very easy and simple, we actually measure how much a material dampens our signal. This is very easy to explain. And a guy from physics would probably be explained a little more deeper, but this is actually it. We work in a radio wave area, so we work with 1 to 100 megahertz. And since carbon fiber is low conductive, we have to work with this high frequency to be very sensitive. What we can do very good is we can see the fiber orientation. So if you have a material having several plies, let's say 0 degree, 90 degree, 45 degree, so we can check for every direction there is in that material. And this is why we use the physics, because the currents, once they are induced into the material, flow with the direction of the carbon fiber. This is why we can see that very well. Of course, we have published some scientific publications. If you need that, you can come to me afterwards. And of course, we won some awards. The last one was last year at the Tech Show in Singapore. Okay, what's the application? What can we do? So first of all, we can check for different carbon materials. So we can check non-woven's, non-crimp fabric. We can do wovens, UD pre-preg. And for example, we also can do recycled material, which gets more and more important. We see that in Germany, where we are located, that there's a company called SGL, and they work very, very much with recycled materials. And what we see is that also in the near future that will get more and more important, because Airbus is now using more than 50% carbon fiber material within the A350. And they started in the 90s in the A320 and A330 series, and the machines have usually 40 years of lifetime. So what we will see in the future is that there will be an increase of carbon fiber, which has to be recycled, and we can provide a right measurement solution. What is the process steps our system is applicable to? This is the yarn, this is the fabric, the pre-preg, also the preforms and CFRP parts once they are cured, and also then the recycled material. What are we looking for? What could be the objective? We are looking for the fiber area weight. We can check the structure, and we can look for defects. Which defects do we look for? This is the fiber orientation. Is something wrong? Are there any gaps, or is there a wrinkle or undulation? Okay. What we mainly focus on is the very early production steps, because there 60 to 70% of the costs are generated. So the earlier you find the defect, the better it is for you. Of course, we can check the cured carbon fiber material, but once it's cured, you find a defect, it's nothing you can do anymore, you throw it away. So this is why we focus mainly on these regions here, starting with the yarn. We have a rubbing monitor, which can check the yarn for fuzz balls or for splices or something if there's something wrong. So also we can integrate our systems into the machines which produce the carbon fiber material. Like here you see a picture of a Karl Mayer machine. We can be integrated into that machine as well. Okay. What is very important to know is that since we work with eddy currents, we just see the carbon fiber material, which is very important. That means we are blind to anything which is non-conductive, which resin is. So you see here the two boxes. The red box is the fiber errors, and the brighter box is the matrix defects. And the matrix defects we typically don't see. Now there's something like delaminations just on the border. If there are tiny delaminations, we don't see them. If the delamination gets bigger and there's air between the layer, then we might see it because the conductivity of the air is, of course, different than of the carbon fiber. But mainly we focus on that fiber orientation, fiber area weight, undulation, fiber uniformity, ply orientation, gaps and wrinkles. That is very important. And again, you see here on which process step is where is it applicable to. That is published by BMW. And since BMW is working with carbon fiber material as well, very strong in the i3 and i8 series, we have took that into the presentation because it shows you where you can use eddy current measurement systems. And you see in the beginning of the engineering and research and development phase, you can start to use it. And you see also other systems, but they go down to the end, except for ultrasonics, but ultrasonics just check the metrics. So for the carbon fiber, actually just eddy currents is increasing and giving you the non-destructive testing method you need for the whole production or life cycle from the beginning, before the beginning of production, going into the production, and then in the end coming to the recycled material again. Okay, here are the main topics we focus on. So we can do analyzing of texture, and we can detect defects. We're looking for fiber area weight and the isotropy, and also we have customized and combined testing solutions. Oh. Okay, here we go. Here you see a short video showing my colleague, and that shows you a typical system, how the orientation scanning would look like. So you put a part into the machine, and then it scans from left to right. You see it again. And this can give you this picture showing the orientation of each ply. Okay, this is a more specific slide. Here you see that you have several layers with several orientation within the material. For example, you see here 45 degrees, 90 degrees, 40, minus 45, and plus 45. And what we can make visible is all the defects within these different layers. And so that if you got an undulation and it's a third or fourth ply, we will see that. So it doesn't matter whether it's hidden. And this is the beauty of our system, that we can check within the material and giving you such a picture of these layers going in different directions. Yeah, this is a screenshot from our software. And if you're not seeing that every day, then you might not be familiar with it. But what you see strongly is the noise, what you get when there's an error in here. So this shows you a sample with no defect, no anomaly. And this one has a strong anomaly. And you see it here that there's an undulation as well in this picture. So that means that the fiber is not placed in the right order. Okay. Then we do have gap algorithm. Is if once you produce the material, and sometimes there are gaps because there's a missing toe, or it is out of the right place, and then you get this. You see it here, this little black lines, and that shows our software, and this can make it visible that there's some material missing. Also, we see if there's something wrong in the Z direction. You see it here. You scan the material back and forth, and here you see one layer is coming up, and our software can detect that. Okay. What else can we do? We also check the fiber area weight as mentioned. And here you see an example. Colleague is placing a different material here, and our system shows you the reading of, here in that case, 65 gram per square meter. Or here, and then it's 90. Yeah. What you also can do is you can do a manual mapping with this system. If you have a laboratory system like this, then you can place your sample, move it, manually creating a map of your area of interest where you check the fiber area weight. Of course, we can do that moving. This is a laboratory device, but we also have this into the field in a production line. You see it here. So this is a production line where we integrated a system with 6 sensors. Here you see the sensors a little bit more in detail, and you see that we have the sender and receiver, and the material is running through that sensor setup. This is a real image of where we have installed it, and we have several sensor sizes, but usually you want to cover a big area, so we have a measurement spot here of 100 millimeters, and we can have a data acquisition rate of 50 samples per second. Okay, this is how your software graphic user interface could look like. You see in the first part the grammature profile from each sensor. That means you see where on which sensor right now, which grammature do we have. Then we have the grammature trend starting from the beginning of the roll, and you see how it changes over the length of your material. And this is a digital error map showing you if you have some boundaries where you said this is out of spec, these numbers, showing you that areas with a red box, then you know later on, okay, in that area I have to check my material and change the process that this is not out of spec anymore. Okay. What else can we check? we also can see the the uniformity of carbon fiber material. We can see where you have more or less carbon fiber. So especially for SMC material, it's very interesting. So dark means more fibers, and brighter area means less fibers. But if you see the picture of that material, you don't see any difference. So this is why our system is very handy, because you can see within the material. Here, for example, you see an material from chopped fibers. One after the resin was inserted. So in this case, the resin was pushed from the left and from the right-hand side, and because of the push of the resin, the material was pushed into the middle. Same here. In that case, the resin was pushed from above, and the carbon fiber was pushed down to the bottom, which you actually don't want. So in that case, you can check and you can change your production process. Okay. As mentioned, we also check the isotropy and uniformity of recycled and chopped carbon fibers. We see that this gets more and more important, and we have several different views in our software, so we can see the uniformity, we can see the isotropy, and also the vector. The uniformity shows you the darker areas, the less fibers. The isotropy gives you shows you the more red it is, the stronger the alignment, so in which typically direction it is located. And then you can see with this vector map in which direction it is heading to. So that helps you to calculate your material, how much material you need for a certain physics strengths. For measuring the fiber area weight, especially in the recycle process, we have this tool which helps you within the production just to check out gives you a very quick idea of whether you're in the spec or out of spec. This is a fiber area weight tester. We call it the portable, and this is mainly used for quality control. This is my colleague Richard again at the JEC show last year in Paris, and here it shows you our gap detection system in an inline system, how it would look like into a producing system. And you see that the sensor is moving back and forth, and within your material there you have, let's say, 4 layers. The first and the fourth layer you can check with the eye or with a visual system. But what do you do with the inner layers? What do you do with if there's a missing toe? Then our system can check that. And you see here that there are of course, some gaps between the different material. And also we pulled some strands. This is what Richard is just right now explaining. So we pulled some toes, and our system can show that. And you see here that in that spots here, and here the resistivity is going down. So this is because there's less material. And in that case, we got this very, very strong peak. And we can find these defects even when you not see them with your eye or visual inspection system. Okay, this is a screenshot. Excuse me. That shows you another system we actually built together with the Fraunhofer Institute. We built a robot-mounted sensor which helps you to check the preforms. So if you have a 3D model and you want to see for anything defects within this 3D model, which is very hard to check with a 2-dimensional system, of course, we created that robot solution, and that helps you to check the fiber orientation and also sees any missing toes. And that pretty much can help you within the production process of 3D preforms. Okay, this is just, again, how it works. the different steps of the process. Okay, this is our robbing monitor. As explained in the machine, there are many hundreds of robbings going into the material, and before they are processed to the material, we can check them for fiber cracks, for splices and fuzzballs. Also, we can check the fiber area weight, whether it's true what the producer of that material gave us. And also we can measure the total weight and the level of impregnation. The advantages of this system, which starts in the very early beginning of the production process, is that you have 100% quality assurance, and we can do 100 samples per second, so you can be very quick. Okay, this is a last overview of all our different systems, starting with the textured system. So we have several systems, inline systems, we have offline systems for laboratory device, 3D robot systems, and then we have fiber area weight measurements, also for inline, and at last customized systems like the yarn tester or combined testing solutions. So now I'm at the end of my presentation. So if you should have any more questions, please feel free to ask.